IPv6 doesn't use ARP for layer 3 to layer 2 address resolution. Instead, it uses Neighbor Discovery Protocol, or NDP. The purpose of NDP is, as you might have guessed, to discover other IPv6 devices or neighbors on a network. NDP is defined in RFC 4861, and it includes features that are similar to IPv4 processes like ARP and ICMP redirect, features used, of course, for discovering neighbors. So other than discovering neighbors, what is neighbor discovery used for? Well, for starters, stateless address auto-configuration uses NDP to automatically determine the network prefix, default gateway, and other configuration information. It's also used to determine whether a global or a link local unicast address is already in use. This is called duplicate address detection, or DAD. NDP is also used for layer 3 to layer 2 address resolution, again similar to ARP in IP version 4. There are 5 ICMP version 6 messages that NDP uses, 4 of which we're interested in: router solicitation, or RS, router advertisement, RA, neighbor solicitation, NS, and neighbor advertisement, or NA. Are you seeing a pattern here? A router solicitation, which is ICMP version 6 type 133, also called an RS message, is typically sent by a host, generally a computer, when it needs network prefix, prefix length, or default gateway information for Slack. This ICMP v6 message is sent to the link local all routers multicast address, which is FF02::2. Now, assuming that the host has no IPv6 address already configured, the packet is sent with the unspecified all zeros source address. Now, 2 things to note here. First, the FF02::2 multicast is not routable. It's link local. So this multicast will only reach routers on the same link. Second, IPv6 routers will not route any packets with an unspecified source address. It will process them, but it will not route them. If there's an IPv6 router on the link, it will send a router advertisement, which is ICMP v6 type 134, an RA message to the FF02::1 multicast address, which is the link local all nodes multicast, with the prefix information. The host then assigns itself an IPv6 address based on the prefix information and the modified EUI64 algorithm. It also installs the responding router as its default gateway. Now let's look at neighbor solicitation and neighbor advertisements. NS and NA perform 2 important functions: address resolution and duplicate address detection. So let's start with this first one, address resolution. Suppose that R1 here needs to ping R2's global unicast address, which is 2001:DB8:12:2, but it does not have layer 2 information for R2. Now we're assuming that this is an Ethernet link, so it needs a MAC address. Well, R1 sends a neighbor solicitation message to the solicited node multicast address containing its source IPv6 address and MAC address, as well as the IPv6 address it needs to resolve. Now, the neighbor solicitation is ICMP v6 type 135. Now, what exactly is this solicited node multicast? Well, it's a special multicast address that an IPv6 device assigns to itself, and it's based on the last 24 bits of the unicast address. Once R2 receives the packet, it responds with a neighbor advertisement, or NA message, containing its layer 2 address. The neighbor advertisement message is ICMP v6 type 136. R1, once it gets this message, then stores the layer 3 to layer 2 mapping in its neighbor cache, and at this point, R1 can ping R2. Pretty easy. Now let's look at duplicate address detection, or DAD. Suppose we configure R1 with a link local address, FE80:12:1. Now, before R1 even tries to use this address, it sends out a neighbor solicitation, or NS message, to the solicited node multicast of the address it wants to use. If another IPv6 device on the link has that same link local address, it will respond because it will have the same solicited node multicast. Now, R1 sends this packet from the unspecified source address because it doesn't yet know whether the address it wants to use is already in use by another device. If nobody else on the link has this address, R1 will get no response. It will get no neighbor advertisement, and after a period of time, it'll go ahead and just use the link. By the way, duplicate address detection is done anytime an IPv6 address is assigned, even if you're using Slack and EUI64. So, now that you have a theoretical understanding of IPv6 address assignment and neighbor discovery protocol, let's go to the CLI and start configuring some IPv6 addresses.